Hello. In this video, we're going to talk about transforming functions, which is just changing them, changing their shape, size, or direction. And we're going to do it by changing a function f of x by introducing these other variables, which will just be numbers. But I'm going to show you what each of these variables does to f of x. All right, so there are a lot of letters here, and there's a lot to get through, but we can do it. Let's get through each one of these. F of x plus d or f of x minus d? F of x plus d is going to shift the graph up d units, and minus will shift the graph down. Now, because we're shifting up and down, of course, that would affect the range. Now, f of x minus c and f of x plus c, whereas you can see these are inside the parentheses, minus c, I listed that first because that actually shifts to the right, and plus c shifts to the left. You may want to make a note that this is opposite of what most people think. Whenever people think minus, they want to shift the graphs left. But because we're shifting left and right, this is an effect on the domain. All right, the next, if we have a negative f of x, this is a reflection about the x-axis. It flips the graph over the x-axis, and that'll affect the range. F of negative x, if the negative's inside the parentheses, that reflects about the y-axis. And I'm going to show you examples of all these. All right, and so far, let's pay attention here. Everything that's like outside of f of x, all of those things have affected the range. Whereas all the things that are directly affecting x, well, those affect the domain, which makes sense, right? It's directly affecting x. All right, let's keep going. All right, if your function is being multiplied by a number, if that number is greater than 1, there's a vertical stretch. And if that number is between 0 and 1, there's a vertical compression. We've already talked about if it's negative, that's up here. But just like if you have numbers like a half or whatever, that's a vertical compression. And what we do is we just multiply the y values by that number. All right, finally, f of bx, where the b is directly multiplying this x. Just like up here, it's opposite of what you might think. Whenever b is greater than 1, it's actually a compression, making it smaller. And if it's between 0 and 1, it actually makes it a wider graph. It's stretching it in the horizontal direction. And to find those values, pardon my little graph here, it's actually we are going to divide the x values by b. Whenever we have to do multiple transformations, this is the order that we're going to do it in. Any horizontal translation, which was the c, any stretching or shrinking, then any reflecting, and then finally the vertical translation, which is just moving up or down. For the next few problems, we're going to let this function right here be f of x. And we're going to apply some transformations to it. Take notice of these key points. Negative 4, 3, negative 2, negative 1, 1, 4, 2, negative 2, and 3, 4. Those are the points that we're going to be transforming. All right, so here's that function f of x. And what I want to plot is f of x minus 2 plus 1. And we check our table and we see that this means that we need to shift every single point to the right 2 and up 1. So here we have that graph. Let's just check a few of the points. The very first point was negative 4, 3. Shifting this to the right 2 should take us to negative 2, 4. And right here, this is the point, negative 2, 4. We can just check one more point and then we'll move on. Shifting this to the right 2, I count 1, 2 to the right, and up 1, I should be at 0, 0. And as you can see over here, I'm at 0, 0. So shifting right and left and up and down, they don't really change the shape of the graph, they just move it around. All right, now let's take that same function and try to do negative f of x plus 1. From our table, we see that this is a reflection over the x-axis, and that this means that we need to move it left 1. And then from the order that we saw, we know that we need to move it left 1 first and then reflect it over the x-axis. So moving all of the points left 1 creates this graph. And don't feel like you need to draw every single step. But next we need to reflect each of these over the x-axis. And reflecting over the x-axis, what's going to happen is each of these y values are going to change signs. So as you can see here, once we reflect all these points over the x-axis, all the y values did change signs. Negative 5, 3 turned into negative 5, negative 3, negative 3, negative 1 turned into negative 3, 1, and so on. In this example, I'm going to draw right on top of f of x, and I'm going to draw 1/2 of f of x. Because this is 1/2, this is going to be a vertical compression by a factor of 1/2. And remember, for this type, all we have to do is multiply the y values by a. So this negative 4, 3 becomes negative 4, 1.5. Because 1/2 of 3 is 1.5. Negative 2, negative 1 becomes negative 2, 1/2. And so on. 0, 2 becomes 0, 1. 1, 4 becomes 1, 2. And so on throughout the points. And so, as you can see, the range is affected because the graph is half as tall as it once was. Now in this example, let's do f of 2x, which we should remember from our table is a horizontal compression where we have to divide the x values by this number 2. So we actually say that this is a horizontal compression by a factor of 1/2. So remember, with horizontal compressions, it can be very easy to get confused that this 1/2 and this 2, it's always 1 over this number is the factor. So see if you can do that. Just divide the x values by this 2. And here I'll help you get started. Negative 4, 3 becomes negative 2, 3. And negative 2, negative 1 now is negative 1, negative 1. You can start seeing what's going to happen to this graph. Finish it out. So all the points got squished in together to have a horizontal compression. Which, as you can see, it's as if you're grabbing the graph from each side and squishing it in from the horizon. All right, and the rest of these, I mean, you can combine these in a million different ways, so I don't want to make these notes half an hour long. But they all obey the same rules, and what's crazy is that all functions that we're going to study obey these same rules. That's why I just used general functions today rather than very specific ones that we'll be learning all year. Anyways, all right, we'll practice, I promise. Goodbye.